Hello, Math 20-1. Welcome to quadratic functions. And it's just a continuation of our travels through this world of quadratics. So up until now, we've talked about these abstract quadratic equations, and we got two answers. And now we're gonna just go a little bit deeper into something called quadratic functions. If you were to look at the link that's on your notes, you'll see there's some amazing things. If you YouTube or Google applications of quadratic functions, you'll see some amazing things, and I'll show you that in class. For now, we're going to carry on and look at the basics of what parabolas are. So a quadratic function is a function determined by a second degree polynomial. A quadratic function has a defining equation that can be written in the form f of x equals ax squared plus bx plus c, where a, b, and c are real numbers, and a cannot be 0. All right, so if you think of a second degree polynomial, a second degree polynomial is anything that has a degree of 2. So if you were to write some examples, we could have any simple y equals x squared, y equals 5x squared with maybe a 2x. It doesn't matter what a, b, and c are as long as the degree is 2 and you don't have the value of a being 0, because then if you did, you wouldn't have any x squareds. You have to have an x squared there. Okay? The graph of a quadratic has either a maximum or a highest point. Ooh, how could that happen? Well, if it has a highest point, then it must be a sad parabola. It must be a down parabola. And if it's got a lowest point, as it speaks of right here, then it must have a upward facing parabola, or concave up, as the one suggested there. Every parabola also has something called a vertex, has a line of symmetry that cuts the parabola in half and passes through the vertex. All right. So now let's look at an example and see what this might look like on an actual parabola, and we'll draw these points. So let's just draw, oopsie, pause that. So on your notes, draw one of the parabolas that we have suggested was, well, let's draw a parabola that looks like this. Would be I guess, sort of a happy parabola, an upward facing parabola. And what would be the key points that we've talked about parabolas? Well, we'd talk about this, that's a y-intercept. We'd talk about this, that's an x-intercept. That's another x-intercept. And then this is another important point right there. That's called the vertex. And with that vertex, there is a line, and I'm going to make that a red line. There's a line that splits this parabola in half, and it is called the axis of symmetry. Okay? And so let's just make note of some of these special points. Well, x-intercepts, as we talked about before, x-intercepts are special because at x-intercepts, the y value equals 0. So when you go to find an x-intercept, the y value is 0. Y-intercepts on any graph are really special too, and the key characteristic of that point is that x equals 0. So if you go to find those x-intercepts, y equals 0. So for example, if I was to look at these points on this parabola, this might be the point 2 and 0. This might be the point 5 and 0. And let's make that 6. Let's make that 6 and 0. And then this vertex might possibly be, we're just making up numbers, but this might be 4 and minus 5, right? And if I went over to this y-intercept, this would definitely be 0 for x, and maybe, who knows, maybe it's up at 20, right? Now the last thing that we want to label about this parabola is that this axis of symmetry is an equation. The axis of symmetry is the equation of a line, and this equation would be x equals 4 everywhere up and down this line, or you would write it as x minus 4 equals 0. That's the equation of this vertical line. Okay. Another possibility for a parabola would be a downward facing parabola, and on this downward facing parabola, again, we would have x-intercepts, we would have a y-intercept, we would also have a vertex, and that would give us, Oops, that doesn't look very good. And that would give us an axis of symmetry. So let's put some numbers to these and we'll just make some stuff up. So let's say that this could possibly be, this x-intercept could possibly be, I don't know, let's say this is 10 minus 10 and 0. This would be 2 and 0, making this right here, oopsie, that would have to be minus 2 and 0. Making this right here, I'm going to say that that is minus 6 and let's say it's minus 6 and 4. Minus 6 and 4. Okay, now what does this look like? Well, this could be an x value of 0 for sure, and this y value might be a y value of minus 5, let's say. It's pretty close, okay, based on our scale. All right. Now, if that's our vertex, again, we'll label the axis of symmetry. This axis of symmetry that splits it in half definitely has an equation of x equals minus 6, or you might write it as x plus 6 equals 0, but you have to write it as an equation. And the last thing that we want to draw attention to is the types of parabolas these are, or quadratic functions. Well, this parabola on this side, this parabola over here, this parabola has a maximum. It has a maximum of y equal to 4 when my x value equals minus 6. So this is a maximum parabola, and over on this side, this parabola has a minimum of y equals minus 5 when my x value equals 4. Okay, so there's mins and maxes. All right. In the next slide, you guys are expected to now come up with, a graph and answer A, B, C, and D. Okay, so as we do that, first thing we'll do is let's do A together. And we're not going to get our graphic calculator, we're going to use algebra. And if we use algebra, right, we're going to start off by saying, well, I want to find the x-intercept. That's easy. I'm just going to let y equal 0. And if I do let y equal 0, I'm going to get a quadratic equation of minus 2x squared minus 6x plus 20 equal to 0. And we've talked about this. I'm going to divide this whole thing. By minus 2, and that just simplifies it because it's an equation. So now I'm going to get a nice equation of x squared plus 3x minus 10 equals 0. That factors nicely to x plus 5 and x minus 2, which then gives me x-intercepts of x equals minus 5 and x equals 2. Nice. So I can go up here and say, oh, well, that's pretty nice. I've got 1, 2, and an x-intercept. And then I've got 1, 2, 3, 4, 5, and the other x-intercept. And maybe we'll make those green. That's going to be our parabola, green parabola. Okay. Well, what else do I know about this? Well, in question A, it also asks for the y-intercept. So using algebra, my y-intercept, I can find that by just letting x equal 0. And if I let x equal 0, then I simply get y equals 20. Well, that was nice. So now, somewhere way up here, we don't have to get too crazy. I'm not going to count it all out. But somewhere way up here, there's a place up there, and we'll call that 20. That's 20 units high, and that's my y-intercept. The next thing that asks me to find is the vertex. Now, that's not quite as easy to do. You're going to have to get out your graphing calculator because we don't have the skills to find that right now. So with part B, we're going to have to use the calculator. Now we're going to build some skills to do that. So I want you to fire up your calculator and type this in. Now I've already done that. So we want to get a picture of this. We already know roughly what it looks like, and I could probably draw a sketch, but let's get our calculator out and graph it. So if I type it in there and I type in y equals minus 2x squared minus 6x plus 20, and whatever window we're in, we graph it, and it said in this one that they wanted to graph it somewhere between minus 6, so I'll set my window from minus 6 to 2. So if you set it from minus 6 to 2 and your y min and y max, as you can see, is minus 10 to 10, when you graph it, you're not going to see it all. And that's kind of disappointing because we want to see that value of 20. So best thing you could do is use something called zoom fit. So it's just zoom 0, and I'm just going to press 0. And when I do that, it fits the screen on my calculator to my X values given. Well, now I can go back and I know exactly how to fill in my picture. So I go back to my picture and I fill in, oh, okay, I know what's going to happen. From here, I know my parabola does this. Okay, now the only thing I don't know is I don't know exactly what this vertex point is. And I can see it up there. There's somewhere a peak up there, and I want to find that vertex out. So I go back to my calculator and I ask my calculator, please tell me the vertex. And I simply do that. If you look at this, I simply do that by having to bound in. I can see my maximum up there. So I go to my calculator and I say second calculate. In this case, a maximum, so that's 4. So I press 4 and I say, well, just like when we did, Mr. Zotner did the zeros, you have to bound it. So my left bound might be, well, by there I might just type in -4. Clearly -4 is to the left of that top. And my right bound, well, clearly 0 is to the right, so I type in 0. And now I feel like guessing. I don't really feel like guessing. So it spits out, wait a second, -1.5 and 24.5. That's actually my maximum. I go back to my notes. I go back to my notes and I go, oh, okay, I just found out my vertex. This is good. -1.5, comma, I forgot, -1.5, and I think it was 24.5 was my vertex. And that's a good thing because now I know my vertex. I can now jump on that axis of symmetry. I'll make that red again. So I make my axis of symmetry. My axis of symmetry, don't just call the number. My axis of symmetry is x equals -1.5 or x equals, or x plus 1.5 equals 0. All right, and now, so we're learning lots about our calculator, and the last thing it asked us to do was find the domain and range. And the domain and range can be found by, just looking at this picture and saying, well, my domain is x such that x can be any real number. This graph goes forever wide, but the range, because it has a maximum of 24.5, is y such that y would be less than or equal to 24.5, but it can be a member of real numbers, okay? All right, now the other thing that's really cool in your calculator is some of these values, if you look at your table, go back to your calculator for a second, and go back to your calculator, and if you look at your table of values, you can see a lot of these special places. Look, when y is 0, you got your x-intercept. When x was 0, you got your y-intercept. And if you scroll down a little bit more in this table, whoops, put Mr. K's pen down. If you scroll a little farther in this table, you'll see, okay, well, where's the other one? There's my other, right? There's my other x-intercept right there when that y value is 0. So you can use that table of values and put those numbers there, okay? All right. So now we have a little bit of discussing our ideas to do, right? So if we go to discuss your ideas in your textbook, this is the page. On page 257 in your textbook, I want you just to ponder these questions and answer them, because at this time now we should be able to answer questions 1, 2, and 3. All right. How do you know if a quadratic equation represents a quad function? How do you know if a given equation represents a quad function? That was the key characteristic in our notes, and that was about degree 2. If it doesn't have a degree 2, it's not quadratic. You're not going to get a parabola. How do you know if a table of values? That's one where I've talked enough. I need you to read back in this section and look at a table of values that it talks about here. And there's a characteristic about the table of values for quadratics. And there's something special if you look at the table of values for quadratics. And if you just use your book, I want you to dig and find the answer to this, okay? Lastly, we'll talk about this one together. And again, I'm hoping you're pausing and playing. So pause, which characteristic of a quad function can be identified by this equation? So if it's in this form, think back to what we did. What's the easiest thing to find out? Can you find out the vertex for this? What's the easiest thing to find when it's written like that? Pause and think. Okay, so you can't find the vertex. That's not easy. X-intercepts, you can't find that out very easy. You can't find the axis of symmetry. That's not cool. But man, is the y-intercept ever easy to find, because when you type in x equals 0, the y-intercept is simply equal to c. Whatever that last number is, the y-intercept is just equal to c. All right, so it's a pretty nice question to be able to get. The last thing that we would like to do is a bit of a practical question. So again, I'd like you to go back to your calculator, and now you actually have a practical equation. All right, so if you look at this question, it's actually from your workbook on page 255, but you don't have to go there, it's right here in your notes. If you look at this question, let's get our graphing calculator again. That's going to be a tool we use. So let's go back, and I've got mine typed in there. And so now I'll type in this one, and I'll highlight it. I'll turn my other one off. And when I go to graph this, you'll notice it's not a very useful graph. I only see a tiny part of my parabola. Well, that's because we need to pick some values that work for this. We're shooting a rocket off, so you may not do it really quickly, but I'm going to help you. So I'm going to say, well, it doesn't really make much sense to go into negative time for a rocket. So I'm going to go from -1 out to, we could go 10, and you might have to try. I'm going to go to 12 seconds. So I'll go to 12 seconds, and I'll see what my graph looks like. I go to 12 seconds, and oh, I can see the upper part, but I can't see I can see 2 branches, but I don't get to see my maximum. So I use what I told you before. I use zoom 0, zoom fit, and now I get to see the path of my rocket, just like you would in Mr. Teskey's physics class or something like that. So I see the path of the rocket. This is cool. And now I'm going to answer some of those questions. So let's go back and just graph this first on our sketch, just a rough graph. Let's go look and see what this looks like. So I go back to my notes, and I just graph it. So of course the rocket's going to start at time 0. It gets shot off, it reaches its peak, and comes back to ground. All right, so let's find out. We graphed it, identify the significance of all the intercepts. So I've got an x-intercept, one of them. Let's go back to my calculator. Oops. Let's go back to my calculator and just look at that picture a little closer. Oh, Mr. K didn't quite graph it perfectly. I can see that when I go to my sketch, I should do a little bit better job. This isn't actually starting off at a height of 0. It actually starts a little off the ground. Okay, so I also want you, when you graph this, remember this is time in seconds. We now have this is height in meters, okay? Let's find out all these critical things, the vertex, the intercepts, and then let's talk about what the significance of this is. So we go back to my calculator, and the things we've learned with our calculator, I go second, calculate. First thing I'll calculate, well, let's do the max first. So I calculate 4, and left of that top might be 2, and right of that top might be, well, I know the far side is, so 6, I think. And so somewhere in between there is the peak. So it looks like 5.1. Okay, so 5.1 and 137.55. So I decided to put my vertex in 2 decimal places. That's still not exact, but that's what we'll choose to do. So 5.10 seconds, and this rocket is 137.55 meters above the ground. Good blast, right? I know this is an easy one. This point right here is 10. That's the point when x is 0 or time is 0, it's 10 meters. This point right here, this x-intercept, I know what that is. That, if I use my graphing calculator, right, and we know how to find, well, maybe I'll do one with you. right? Just in case you forgot from quad equations, I want to find the x-intercept. So I calculate the zero. The zero is found by doing left bound, right bound. So my left bound would be -1, and my right bound would be 3. We can pick. I don't feel like guessing, so I get 0.196. So I'm going to round to 2 decimal places, and my x-intercept is going to be minus 0.20 seconds. And I also did this with the other x-intercept, and this one turned out to be 10.40 seconds. Okay. So I found out all the key characters, the vertex, the domain and range we're going to talk about in a second. What is the domain of this? Well, remember from a practical sense, right? So I've identified the intercepts, the coordinates of the vertex. What's the domain? Well, the domain would be time such that now you're blasting off a rocket. It doesn't make sense to go back in time, so I would say time is greater than or equal to 0 and less than or equal to 10.40 seconds. Now, why would I say that? Time is an element of real numbers. Well, because it doesn't make sense for this thing to bury into the ground. So once it hits the ground, it's done, right? What about the range? Well, the range would be h such that h is greater than or equal to the ground, a height of 0, and h is an element of reals. Now, what's the significance of each of these places? Well, I'm going to get a different color. What's happening right here? Well, I guess that's blastoff. This rocket must be right sitting on a launch pad. If you imagine this rocket must be sitting right here, and it must be getting launched into the air. So blastoff is on a pad 10 meters high. Right? It must be, because otherwise, why is it at time 0, 10 meters up? Now it blasts off and it reaches this peak up here. That's the maximum. That's the highest the highest this rocket goes, and that happens at this time of 5.10 seconds. That's when that rocket reaches its height. And lastly, what does this point here represent? Well, that represents it hitting the ground. When does that hit the ground? When the time is 10.40 seconds, the height is 0, and that's when the rocket hits the ground. All right? And now I'd like to carry on with your assignment for 4.1.